C++ is a powerful programming language. It is used to create many types of software. You can build operating systems with it. You can also make complex video games. C++ gives programmers a lot of control over computer hardware. This control allows for very efficient programs. It is known for its performance and flexibility. Many modern systems rely on C++ code. Learning C++ opens doors to understanding how software truly works at a deeper level, providing a solid foundation for any aspiring programmer. The story of C++ began in the early 1980s. I designed it as an extension of the C language. The C language was already popular and useful. However, I wanted to add more features. These features included object-oriented programming. This approach helps organize large and complex programs. C++ was initially called C with classes. It aimed to combine C's efficiency with higher-level programming constructs. This evolution made it suitable for a wider range of problems. C++ remains incredibly significant in the world of programming today. Its ability to manage system resources directly is a key reason. This makes it ideal for software that needs to run very fast. Think about search engines or financial trading systems. These applications demand high speed and reliability. C++ provides the tools to achieve this. Even with newer languages emerging, C++ maintains its place. It is a language for building foundational software components that other systems often depend upon for their core functionality. The applications of C++ are vast and varied. It is a cornerstone in game development. Many popular game engines are written in C++. Operating systems like Windows and parts of macOS use C++. Web browsers such as Chrome and Firefox also rely on it. Furthermore, C++ is used in embedded systems. These are computers inside cars or medical devices. Its performance is critical in these areas. The language's versatility ensures its continued use across many industries, solving complex computational problems efficiently. In C++, variables are essential building blocks. Think of a variable as a named container. This container holds a piece of information or data. You give each variable a name. This name helps you refer to the data later. For example, you might create a variable called. This variable could then store a person's age. Before you use a variable, you must declare it. Declaring a variable means telling the computer its name and what type of data it will hold. This step is crucial for the compiler to understand your program. Data types define the kind of values a variable can store. C++ has several fundamental data types. For whole numbers, you use. For numbers with decimal points, you can use OR, offers more precision. To store single characters like A or Z, you use. There is also a data type. A variable can only hold one of two values, or. Choosing the correct data type is important. It ensures your program uses memory efficiently and behaves as expected. Operators are special symbols that perform operations on variables and values. C++ provides a rich set of operators. Arithmetic operators are very common. These include for addition, for subtraction. You use for multiplication and for division. There is also the modulus operator, which gives the remainder of a division. These operators allow you to perform calculations. For instance, you could calculate the sum of two numbers stored in variables. These are fundamental for any mathematical task within your programs. Besides arithmetic operators, C++ has relational and logical operators. Relational operators compare two values. Examples include for equal to, for not equal to. We also have for less than and for greater than. These comparisons result in a or value. Logical operators such as and, or, and not, combine or modify Boolean expressions. These operators are vital for making decisions in your program. They help control the flow of execution based on certain conditions being met or not. Control structures are fundamental to programming. They allow you to direct the flow of your program's execution. Without them, a program would just run statements one after another. Control structures enable programs to make decisions. They also allow programs to repeat tasks. This makes software much more dynamic and useful. Understanding these structures is key to writing effective C++ code. They are the tools that give your program intelligence and responsiveness. Learning to use them properly is a major step in becoming a proficient programmer. One common control structure is the statement. This statement allows your program to make choices. You provide a condition. If the condition is, one block of code executes. If the condition is another block of code, the part can execute. For example, you could check if a user's age is 18 or greater. If it is, the program might allow access. Otherwise, it might display a message. This decision-making capability is crucial for creating interactive and intelligent applications. It allows programs to react differently to various situations. Loops are another essential type of control structure. Loops allow your program to repeat a block of code multiple times. There are different kinds of loops in C++. The loop is often used when you know how many times you want to repeat. For instance, you might want to process 10 items in a list. The loop repeats as long as a certain condition remains. This is useful when you don't know the exact number of repetitions beforehand. Loops save you from writing the same code over and over again, making your programs more concise. Functions are a way to organize your code into reusable blocks. A function is a named sequence of statements that performs a specific task. You can define a function once. Then, you can call it many times from different parts of your program. This makes your code more modular and easier to understand. It also reduces redundancy. For example, you could write a function to calculate the area of a rectangle. Whenever you need this calculation, you just call the function. This promotes cleaner, more manageable code, especially in larger projects. Arrays are a basic way to store multiple values of the same data type. Imagine you need to store the scores of 5 students. Instead of creating 5 separate variables, you can use an array. An array is a fixed-size collection of elements. You access each element using an index, which usually starts from 0. For example, would be the first student's score. Arrays are stored in a contiguous block of memory. This makes them efficient for accessing elements directly if you know their position. They are a fundamental data structure in C++. While arrays are useful, they have a limitation. Their size is fixed when they are created. Sometimes you need a collection that can grow or shrink as your program runs. For this, C++ offers from the standard library. A vector is like a dynamic array. It can automatically resize itself when you add or remove elements. This provides more flexibility than traditional C-style arrays. Vectors also come with helpful built-in functions. For instance, you can easily find out the number of elements in a vector. They are generally safer and easier to use. Functions play a crucial role when working with collections like arrays and vectors. You can pass arrays or vectors as arguments to functions. This allows you to write functions that operate on these collections. For example, you could write a function to find the average of all numbers in a vector, or a function to print all elements of an array. This practice promotes code reuse and modularity. It helps in breaking down complex data processing tasks into smaller, manageable parts. This makes your overall program structure clearer and easier to maintain. You have now learned some basic concepts of C++. We covered its history and importance. We discussed variables, data types, and operators. We also looked at control structures like in loops. Functions, arrays, and vectors were introduced. This is just the beginning of your C++ journey. The key to mastering C++ is consistent practice. Try writing small programs. Experiment with these concepts. There are many more features and libraries to explore. Continue learning, and you will discover the true power and elegance of C++.